In this presentation, we will introduce you to the ESA mission proposal called LITTER. Bearing in mind ever-growing plastics production and pollution of the oceans with that, as well as potential threats to the environment and our health, and also the absence of systematic approaches to monitoring the plastic pollution in the oceans, with only some sporadic attempts to do that proved to be successful from the technical point of view. Our main purpose of the mission is therefore to track plastic pollution globally, accurately and systematically in order to have more information on its likely sources, global distribution, movements, and possibly even the sinks. We will improve the quality of macroplastics identification and observation, by increasing the spatial resolution up to 1 meter. We will track macroplastics movements in space, establish systematic macroplastics tracking system by launching a constellation of satellites, and we will contribute to Sentinel-2 collaboration for more effective ocean plastic identification even after our mission would have finished. Data product. The technology we propose has been used before on different satellites. However, that has not been implemented within one CubeSat, so there might be some issues, relating to the putting everything together in a relatively small piece of equipment, but it's totally feasible. Level 1 and 2 data would be calibrated and then validated with the UAV and volunteer observations prior to being published. Plastic litter extent data in meters squared would be obtained, as the resolution of imagery would be at around 1 meter. Distances and directions of plastic travel would be known and publicly available on a map with live plastic pollution data.
LITTER is relevant to ESA as it fits within ESA's vision to enable the maximum benefit of Earth observation for science, society and economic growth in Europe. The removal of macroplastics from the ocean benefits marine animals, ecosystems, human health, tourism and fisheries. LITTER supports the Copernicus Marine Environment Monitoring System through the addition of a plastic tracking system. The 14th Sustainable Development Goal, Life Below Water, aims to prevent and significantly reduce marine pollution of all kinds by 2025. LITTER would help towards this goal. LITTER builds upon current ESA missions. It aims to align with the Copernicus Sentinel-2 data to make use of its 2 to 5 day temporal resolution, and build on this with a better spatial resolution of 3 meters. Data from Sentinel-2 and Aeolus provides measurements of surface ocean currents and wind direction. LITTER will utilize these to help track and forecast movement of identified plastic patches. LITTER will contribute to existing marine litter monitoring programs, such as IMDOS and the FDI. Its high spatial resolution will allow for better recognition of ocean plastics, assisting current machine learning systems.
LITTER is a passive optical radiometric mission that comprises a Walker constellation of 6 identical 3U CubeSats deployed on a sun-synchronous circular orbit at 450 km altitude with an inclination angle of 97.25 degrees. The orbital period would be in the range of 90 to 120 minutes. As the CubeSats are at low Earth orbit, the expected swath width would be quite low, perhaps around 7 km, requiring a high number of satellites to attain continuous global coverage. As this number cannot be met with the current budget, we will use the Walker constellation to optimize the maximum revisit time to ideally 3 days. LITTER focuses on the spectral signature of plastic in the shortwave infrared range at 1215 nanometers and 1732 nanometers. As the main purpose of LITTER is plastic detection in the shortwave infrared range, the primary payload would be a miniaturized, custom-designed multispectral shortwave infrared instrument with a bandwidth of 10 nanometers through the spectrum from 1200 nanometers to 1250 nanometers and 1700 nanometers to 1750 nanometers. The secondary payload would be a low-resolution multispectral instrument in the visible range with a high-resolution panchromatic channel. The multispectral pan-sharpening should increase the spatial and spectral resolution of the image, whilst overcoming the onboard size and storage limitations of a CubeSat. The imagers will apply a push broom line scan and will image at different wavelengths concomitantly. The wanted spatial resolution for this mission would be 1 meter in visible and at least 3 meters in SWIR, which is attainable with current technology, especially at the chosen satellite altitude. The visible imager will increase the geolocation accuracy of the data collected in the shortwave infrared range. Moreover, the combination of the two instruments might enhance the atmospheric correction algorithms, which require shortwave infrared data for processing visible channels. The highest challenge raised by nanosatellites is the downlink rate limitation, which combined with large amounts of data, leads to restrictions of the data amount that can be sent to the ground station. A solution would be using an image compression algorithm on board. Another solution would be employing low Earth orbit to geosynchronous inter-satellite links through laser communication. This would increase the data download efficiency from low Earth orbit satellites by 98%. Mission LITTER proposes that the level for data output should be an online interactive platform showing the plastic sources, sinks, and trajectory at the ocean surface.
Moving on to the programmatic elements, in terms of the lifespan of the satellite, in line with other low Earth orbit missions, the proposed lifespan will be 3 years. Regarding the timeliness of the mission, CubeSat subsystems can be off the shelf from suppliers and put together very quickly, so it could be ready within 1 to 2 years. CubeSats piggyback on other launchers, so we will need another satellite that is going into the same low Earth orbit. The 3U CubeSat will be enclosed in a polypico satellite orbital deployer, which minimises the interactions with the primary payload and the CubeSat. But the use of this P-pod means that the CubeSat can be launched into virtually any launch vehicle, which is a real positive. The costing of the mission has not yet been determined, but we do know that CubeSats are much cheaper than normal low Earth orbit satellites. However, there are additional costs with the launches as they have to piggyback, so a normal cost is about $100,000 per unit for launching. The data from the satellite will first be stored in a geo, which provides secured access to the whole data sets. It is then hoped that data will be used in IMDOS, which is the Integrated Marine Observing System, which is a proposed observing system for integrating remote sensing and in-sea observations to support activities to remove ocean plastics. Very briefly regarding the methodology of the mission, the satellite will use the Floating Debris Index, which was developed by the Plymouth Machine Laboratory, and will then use a Bayesian machine learning approach to train the satellite, and through this machine learning it classifies a detected pixel to the index and determines the probability of this correct detection, which is then done over and over to train the satellite. There have been many previous studies that have shown the potential for the detection of plastics using satellites, hence the justification that the data products from this mission will be useful. It is key to highlight the last study here that optical imagery by Sentinel-2 has the potential to detect plastics if it is trained with high resolution imagery, hence the use of this mission and the use of a high resolution CubeSat.